Hi, my name is Stuart Lynch, and in this video, I want to help you understand trailing closures and Swift's trailing closure syntax, and help you make sense of some of the different initializers for controls like buttons and lists in SwiftUI. You often hear people talking about making your code more Swifty. What exactly does that mean? I suppose it means different things to different peoples, but really what it means is to write idiomatic Swift, and by this I mean to write code that looks and feels like Swift, including Swift-specific language constructs and conventions, and to avoid patterns that might be more common in other programming languages. A big part of this is the trailing closure syntax that is used. As Swift evolves, the language changes. As recent as Swift 5.3, the introduction to multiple trailing closures made for a simpler way to call a function with several closures, and this made for simpler, more readable constructs for things like buttons. Anyway, I'm getting ahead of myself. Let's go back to the beginning. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. I prepared a starter playground book for this video, and I encourage you to download it from the link in the description and work along with me. That way, when completed, you'll have a working example with code that you may be able to reuse in the future in your own projects. The book will allow you to switch between different pages using the introductory navigation page or by tapping the navigation links at the top or the bottom of each page. If you're not seeing the page as rendered markup and it looks like this, make sure you choose Show Rendered Markup from the Editor menu, and you can reveal the sidebar too if you want to switch between pages that way. Before we talk about trailing closures, let's first take a look at what a closure is. In Swift, a closure is a self-contained block of functionality that can be passed around and is used in code like a variable. It's similar to a function, but it doesn't require a name or explicit use of a func keyword to define it. Closures in Swift are defined using curly braces and can be assigned to a variable, a constant, or passed as a parameter to a function. I have a complete video on this topic, so if this very brief introduction is not enough for you, please check out this video. I'll leave a link in the description. This goes into more detail about closures, but here I want to focus on trailing closures and in the end how they apply to SwiftUI syntax that we use all the time. Let's start by looking at this function called sayHello. The function has no parameters and no return values. The body of the function is just a statement that will be executed. So to call this function, we simply use the function name and include an empty set of parentheses. The function signature is either 2 parentheses followed by an arrow followed by another 2 parentheses, or 2 parentheses followed by the arrow and then void. The void syntax is preferred because it's more explicit about the fact that the function returns nothing. The first example can be interpreted as a function that returns a tuple with no elements, which can be kind of misleading. Additionally, the void type is commonly used throughout Swift's standard library and in many third-party libraries, so using the parentheses followed by void can help maintain consistency with the rest of the codebase. If we want to create a variable to represent this function, we can do this by creating a constant or a variable and specifying the type as that function signature, and then assigning to it the body of our function within braces, like this. And then we execute this closure in exactly the same way as we call the corresponding function. sayHello. Well, Swift is known for type inference, and this means that if it can, Swift will infer from what is being assigned to a variable the type of object that it is. So we don't need to do something like this. Let x, specifying it's an int, be equal to 5. Because Swift knows that 5 is an integer, so simply specifying let x equals 5 will suffice. Similarly then, in our example, we can choose to write the variable simply as let sayHello equals, and then our braces enclosing our print hello code. So to execute this closure, we do exactly as we did for our function. Simply say hello. We may, if we wish, add a parameter to our function definition that we can pass in from the call site and have our code use that in the function body. For example, we have this function here that is expecting a string that will be assigned to a variable named name that we can use to print hello with string interpolation, the person's name. When we call this function, we need to pass in a string as an argument to our function call. For example, say hello, and then within quotes, Stuart. We can represent this type of function as string returning void, meaning returning nothing. If we want to create a variable then that we may wish to pass around in our code, that is this function, we can create a closure, and we can do this in two different ways. We can create the variable and specify that the type is this, where we specify the type as we create our variable, and then the function body will provide a name for the closure parameter, and then we'll use the keyword in to let our following code know that we want to use this variable, which, because of our function definition, must be a string, in the code that follows. And then we can execute our closure the same way we called our function. Simply say hello, and then within that quotes, Stuart. Notice that this time there is no label for our name variable. Alternatively, we could use type inference and specify the body of our closure what the type name is. This will require that we enclose the variable and the type in parentheses. As we move on to passing in closures as function parameters, it's that first syntax though that we'll need to use, where we specify the function description type when we create the closure. On this second page, let's take a look at how we can use a closure as a parameter for a function. So let's take another look at that function that we created on the first page and do one more thing here. I want to be able to remove the parameter label so that our function call will be simpler. Right now, to call this function, we must use say hello and then provide the label name before we provide our string, Stuart. But we can change the function parameter by adding an underscore before the label name. Now, when we call this function, we simply use say hello and then just use Stuart as a string without providing the label. Now I want to add a second parameter to this function, and I want it to be a closure. So all subsequent parameters must have a label, and you always need to specify the type of object that it is. We're going to use one of the two different closure descriptions that we used on the first page here, and we'll create a closure that has no parameters and returns nothing or void. Now, since this closure is the last parameter in our function definition, it is referred to as a trailing closure, and this is very common to see the label used being completion, as it's the last one. So we'll define it as this. Well, for the body of our function then, we can continue to print hello, and if we like, we can perform more code after this that might take a while to process, but in the end, once we have done all of our processing, we want to execute the closure so we can simply execute the completion handler by calling it by name as we did previously. To call this function then, we'll need to use two parameters. The first one does not have to have a label, so we can just pass in a string. The second parameter has this label completion that we'll need to provide the body for what will be a block of code that requires no parameters. For a block of code then, we can simply print out the string done. When this function is called then, it passes in both arguments to the function, and the first thing it does will print the hello Stuart string, and then it will run the completion function which we passed in, and which is in our case simply to print the string done. Well, we can simplify this even more now though using trailing closure syntax. If I copy that same function now to the next example, let me show you how this can be simplified. We can take the final closing parentheses and move it after the first parameter to close it off, and then remove the label of the closure function. Let's take a look at this one more time, but slowly, because this is the key to trailing closure syntax. Here's our function. When we make a call to this function, Xcode provides us with two placeholders for our two arguments. The argument with the label name is a string, so it needs to be replaced by the string. The argument with the label completion requires the label, and it is a closure that requires no parameter and returns nothing. So we can simply set up our closure using a pair of braces. Now it's common practice to separate this so that the opening brace is on the same line as the label, and the closing brace is on a separate line. And then within those braces, we can create our function code, which in our case is to simply print the word done. Well, to change this then to the trailing closure syntax, we can move this trailing parentheses up to include our first argument, which is the name. And then we can remove the comma and the next label. In fact, this is so commonly used that Xcode will more often than not do this for you. In fact, if we start over from scratch on this function, we can enter our name as a string, and then we can tab to the second closure parameter until it turns the highlight color, which in my case is blue. And then if I hit enter, Swift will move that closing parentheses and remove the label for you. For the last example on this page, consider this version of our say hello function. This time it has the first parameter, but our completion closure is one that has a string parameter itself, and it still returns void or nothing. Within the function body, we start by printing out our greeting as before, but after that, I'll create a new variable that I'll call reverse name, that simply is a reverse of the characters in the name. Well, now that we have that new string, I can use that as the argument for our completion function. Now when I call this function, I pass in the name, and then when I tab to the closure and tap enter, it'll convert this to a trailing closure again, and this time it knows that because our function definition requires that this provide us with a string argument. We can use that and give it a name, and then in the body we can use that variable in our code to print out your name reversed is, followed by a string interpolation of that name. When we execute our code then, the say hello function will print out the greeting, reverse the name, and then execute whatever function we passed in using the reverse name, which in our case is simply to print this statement. In our previous example, we had a single trailing closure as a parameter for our function. Let's take a look at this more complicated function here. It is a function called performTask that has 4 arguments. The first is an integer that will be assigned to the label value. The second parameter is a closure with the label onSuccess, where it is simply a block of code that we can pass in with no parameters, and it returns nothing. The next parameter is another closure called onFailure that has an error parameter, and it returns nothing. And then the final argument is once again another closure that is called onProgress that has a double as its argument and returns nothing. Well, the body of this function first checks to see if the value is an odd number using the modulo function to see if, when dividing by 2, we don't get 0 as a remainder, meaning it's odd. And if it is, we can call the onFailure closure and pass in an error type. And that error type is this task error, and we use the only case, which is odd number. Now, if it's not an odd number, we'll step up from 0 to the value passed in, and for each iteration, we'll call the onProgress function that will create a double value by dividing our step iterator by the value, thus creating some double between 0 and 1. Once the steps have been completed, the onSuccess closure is called. So let's see how we can call this function. In fact, we can write a call to this function in 4 different ways. For the first version, it will not be very Swifty at all, and not use any trailing closure syntax. It's common practice when having trailing closures and you want to use the labels is to include the first label on the same line as the previous argument and start your brace after the label with your code, followed by a return, and then your code. So let's pass in a value of 10. Now the second closure is going to require a variable for our error. So let's create our first brace and enter error for our first variable to be used in, and then press return, and then we'll be able to use this error in our code. For the final closure, it too will require an opening brace after the label and require a variable name for our progress. So let's call it progress, and then we can use that in our code. For the first closure then, which is on success, we can simply print out done. In the case of a failure though, i.e. when the number is odd, we can see that this produces an error, and we are specifying in our function that it's an error of type task error with the case odd number, which has a localized description, so we can simply print this out in our code. And as our app is in progress, it is emitting a double value that we can print out in the body of our onProgress closure. If we run this code now, we see that it'll print up the numbers from 0.0 up to 1.0 and then print out the string done. That's the progress followed by our success. Now, as I mentioned, this isn't very Swifty, so let's take a look at how we can use trailing closure syntax here. So copy the code from the first example. And what you can do then is remove that closing parentheses from the last or at the end and move it up to close after the onFailure argument. Then we can remove the comma and the label from the onProgress just as we did on the previous page. Testing, we see that it provides us with the same result. So let's copy that first example once more and paste it into version 3. This time we want to move the closing parentheses up to enclose the first two arguments, the value and onSuccess. When I've done that, I can remove the comma and the label for onFailure, but I'm required to keep it for onProgress, but I do have to remove the comma separator for the closure argument because a comma is only used within the function parentheses. Once again, a test reveals the same result. For version 4, I only want to enclose the value argument. So once again, I'll copy the first example, then move up the closing parentheses up to only include the value argument, and then I can remove the comma and the label for onSuccess, and then remove the comma separating the following closure arguments. One more test verifies that our adjustment is valid. Now let's see what version Xcode auto fixes for you. We'll start by entering the function call to get your code completion. Again, I'll enter 10 as the value, and then I'll tab to the next argument, the onSuccess closure, and press enter. This then replicates our last example. It converts the rest to trailing closure syntax. And we can use the same code and the same variable names to achieve the same result. There you have it, the same as our previous and final example. It encloses the first argument and uses trailing closure syntax for the remaining arguments. Now we've not yet verified what happens if our function generates an error. We can do this by passing in a 9 instead of a 10 for our value. If I run this now, I get that error's localized description printed. In this example, I want to see how all of this applies to SwiftUI, so we can understand why, when looking at other people's codes, things might look a little different from yours, but still function the same way. On the buttons page, we'll have a SwiftUI view with a VStack. If you run this playground, you'll see you'll get the option to show a live view, and when you do that, you'll get a 300 by 400 frame. Within the VStack, I want to create 5 buttons that have similar actions, but all created using a different initializer format. When you create a button, Xcode offers you a number of initializers, but the two most common ones are these ones here, where there is a button, an action, and a label, or a button with a title and then an action. Let's look at that title action button. As you see, when you highlight this constructor, it tells you that it creates a button that generates a label from a string. Well, the button is like a function, and what you are seeing here is that function arguments And the first has a label of title that's not required because of the underscore. And the second is a closure with the label action. And it is a closure with no parameters, just the function body. So we can write it just as we did in our function. Now, if we don't take any suggestions from Xcode, we can add button 1 for the label. And the action is a closure, so we'll just replace that with a pair of braces. And for the code, we'll just print the string button 1. Let's add some button style to the VStack of a bordered button style. I run this in the playground. We see the button appears, and if I tap on it, it'll print button 1 in the console. But as you see, this action is a trailing closure. So let's copy this version and paste it below in the VStack, and we'll use trailing closure syntax. We can move that closing parentheses up to enclose the first parameter, and then remove the comma and the label for the closure. And then we can rename it as button 2 in both places. When we run the playground, it works as designed. Now, if you want to use anything more than a string for a label for a button, we'll need to use that second constructor for our buttons, and that's the action label constructor. That'll place the action closure first. This action closure is the same as before, but the label looks pretty similar to another closure. In fact, it is. It's a closure that has no arguments, but it returns a view. So we can specify any view we want to act as the label for our button. So for the action then, we'll create our closure, and we'll just print button 3. For the label, we'll need to create some UI view. We'll start our closure with the 2 braces, and then within the braces, we'll create the view that we want. So let's just create an image using the system name plus .circle.fill. Well, this is pretty descriptive, but it's not very Swifty. So let's copy and paste this as our fourth example. This function has 2 trailing closures, so we can move the closing parentheses up to enclose the first argument, and then we can remove the comma and the label for the label. And let's change the action to print button 4 too. You can see this code quite often, but since version 5.3, we can do even better. So let's copy that third example once more. Now I want to move this clothing parentheses up to before the first trailing closure so that we can get an empty set of parentheses, and then remove the label from that action closure as it's the first one, but just remove the comma for the label closure. Let's also change the action to print button 5. And this works. And one more thing though, since our arguments are trailing closures, we can even remove the parentheses. This is how I like to create my buttons, and in fact, if we take a look at how Xcode suggests this for us, we can see that it suggests this format as well. For this final example, I want to take a look at SwiftUI's list and how it is constructed, and show you one more thing that we can do with closures. Currently, this SwiftUI view has an array of strings assigned to a constant called items. We can present these in a list. So I'm going to replace this text view with a list constructor, and as we enter list, we see a number of choices. Since we have data, we'll choose the one with data, and we want to use the row content, so our construct will allow us to use that data. Now we don't have a range of items, but rather a random access collection that we can create a list with and compute the rows on demand from the underlying collection of identifiable data. We'll see that for the first argument then we can specify our items array. It's a random access collection. The row content should look familiar to you now. It's a closure that requires an argument that we can specify using the variable iterator that I can call item to be used in the creation of our view. Well, we get an error because our random access collection must also conform to the identifiable protocol. And right now, it doesn't unless we specify an ID. Now, since all of our strings are unique, we can specify that the ID is the key path of self. For the view then, for our row content, we can simply specify a text view displaying the iterated item. If I run this now, we see that the list is generated. Well, you'll almost never see it written this way because we normally will let Xcode fix the trailing closure syntax. But we know how to do that. We can move this final closing parentheses up to enclose our first argument, and then remove the comma and the row content label. Now, if you're still with me, let me do one more thing. Let's change this array to be a private state variable, a mutable object. So let me comment out this list for reference and start again by just creating a list with no arguments. And then within the list's row content closure here, we can use a for each loop to generate our row content. Now notice when I start typing for each, we have basically the same constructor choices that we had for list. We'll need a random access collection in which we can specify our items, but the content generated will require that it be an identifiable random access collection. So again, we'll need to specify an ID. Then if we tab to the second argument, that closure, we can tap enter, and Xcode will allow us to enter our name for our variable. So we can specify item again. And then we can construct our table row view just as we did before, and that's the text view specifying that item string. Now the advantage of creating our list like this is that we can now add an onDelete method for our for each loop. And this method has a trailing closure that will provide an optional index set to work with in our closure body. So we can simply tap enter to remove the perform label and create the placeholder for us that I'll call index set. For the body, then we can mutate our items array by invoking the array's remove offsets function that requires an index set, and that's what we have. So we can just pass that in. Now when we execute the playground, we can swipe to delete rows. Now, one last thing though that I know confuses a lot of people, but hopefully after sticking with me this long, it'll make some more sense to you. Let's create a function outside of our body that will represent the onDelete's closure. And we see that this closure must be a function that has a single parameter that is of type index set. And the function body will simply be just what we have. So we'll create that function delete row with that argument index set of type index set. And the body will simply be the same items removed at that offsets of index set. Now let's comment out this onDelete function and start again, but this time not tap enter, but rather leave the closure label name perform, and that closure requires an argument that's an index set and returns nothing. Well, that's exactly what our delete row function is. So we can replace the performs closure simply by entering the name of our closure. And Xcode likes to include the label, but it's not required at all. In fact, we can remove it and the parentheses and just leave our function name. The onDelete function is performing the delete row function because the function argument is an index set, so we can leave it out. I hope this video has brought some clarity and understanding to you with regards to trailing closures and trailing closure syntax. Remember, if you've enjoyed this video, please give it a thumbs up and leave a comment. I'd really appreciate that, and it'll encourage me to create more videos like this. Thanks for watching.